Hey guys, welcome to your Chapter 5, Lesson 8 notes on graphing absolute value equations. It will be absolutely so much fun. Okay, by the end of the day, you'll be able to graph an absolute value function and to translate the graph. When I say translate, I don't mean like talk about the graph in Spanish, although that would be super fun, and if you want to, we can do that. Translate is like move the graph or shift the graph up and down, left to right, that kind of deal. So here I am talking about absolute value, but what does absolute value even mean? Well, absolute value, you'll remember, is a number's distance from zero. So if I have like 3 over here, right, that's 1, 2, 3 away from 0. So the absolute value of 3 is 3. But guess what? The absolute value of -3 is also 3 because it is exactly the same distance away from 0. So the absolute value of -3 is in fact 3. So think of that. That's technically what absolute value means. I just think of it as don't put a negative on it. So does it have a negative? Take it away, it's 3. Does it have a negative? No? Okay, cool, it's still 3. So that's exciting. It neutralizes the negative. There you go. Okay. So now, is it greater than, less than, or equal to? The absolute value of 3 is 3. Absolute value of -3 is 3. So these are equal. Cool. Here, the absolute value of -3 is 3. The absolute value of -1 is 1. So the absolute value of -3 is greater than the absolute value of -1, which is a little confusing because -3 is actually less than -1, but it's further from 0. Check it out. -1 is right here. And since -3 is further away from 0, that is greater than the absolute value of -1. Here, 9 by itself is greater than -10, but the absolute value of 9 is 9. The absolute value of -10 is just 10. So the absolute value of 9 is less than the absolute value of -10. Here, the absolute value of -9 is 9. Absolute value of 8 is 8. 9 is greater than 8. Therefore, the absolute value of -9 is greater than the absolute value of 8. So based on what you know about absolute values so far, is it true that the absolute value of a number is a measure of the distance from 0 to that number on the number line? That is so true. That is cierto. That is true. Okay, then is it also true that the absolute value of a number is always the opposite of that number? Remember, opposite means negative. And if you have a negative number, like -3, the absolute value of -3 is its opposite, 3. But the absolute value of 3 is itself 3. So this is going to be falso. That's false. Okay, cool. So now here's how to graph absolute values. I'm going to talk about a translation, like the math term of a translation. Translate means you move. Okay. Or you can think of it as a slide. I'll show you why. And translations don't just apply to absolute values. They can apply to any kind of graph, but here we go. So here is our parent function y equals x. It is just this guy right here. And by y equals x, I mean y equals the absolute value of x. You'll notice that when I graphic, the absolute value of 0 is 0. The absolute value of 1 is 1. The absolute value of 2 is 2. The absolute value of 3 is 3, and so on. So on this side, we have basically the graph y equals x. Cool. But on the other side of our y-axis, we don't have that. We have something different. Check it out. At x equals -1, the absolute value of -1 is 1. The absolute value of -2 is 2. The absolute value of -3 is 3. So absolute value makes this kind of V shape on this side of the y-axis. We don't have y equals x. We have y equals -x. That's great. But on both sides, no matter what x is, take that value, make it positive. Just keep it positive. Absolute value keeps it positive, guys. And that's what it looks like. It looks like this V guy. So we're going to take this V guy, and I'm going to put the parent function here on our normal graph. So the point is always at 0, 0. And the trick to seeing how an absolute value function moves is you just see where the point goes. So look at this point. What is the point doing? Where's the vertex of your V going? Well, here we take the vertex of our V and it shifted down 2. And that's what this guy represents. That's down 2. So we have a shift of down 2. Now notice we have a new kind, so this was absolute value of x minus 2. This is the absolute value of x minus 2. So when you have your number inside your absolute value, we're not going up and down, but rather we are going left and right. So here, we took our point, come back to me, point. We took our vertex, and our vertex goes to the right 2. So when we have this minus 2 inside, that means that moved to the right 2. But those were both minuses. I'm going to keep it positive and show you how it changed. Okay, here we go. So we already talked about y equals the absolute value of x as the parent graph, that's like the main guy, of absolute value functions. Now, if you have a positive number, and then so k is any positive number, that's important. Then when you have plus k outside of the absolute value guys, that's going to translate the graph up k units, because here we had down 2, we had negative 2, and that went down. So positive, the opposite direction must go up. And then similarly on the other side, when k is hanging out inside of our absolute value brackets, just like he's in the absolute value inside right there, when it's positive, here it was negative and we went right, so the opposite of that, we go to the left, k units. And that's our key idea. And you know what, guys? Here's my helpful math hint and my good life hint for you. Take your key idea, put it in shorthand, and put it at the top of what you're going to do next. So I'm going to take this and I'm going to say, okay, well, y equals the absolute value of x plus k means you go up k. So when it's on the outside, that means up. And then when it's on the inside, y equals the absolute value of x plus k. On the inside, that means we go to the left, okay. And now that we have that key idea up on the top, we don't have to keep like switching back and forth, but so do that, write that on your homework too. Write that at the top of your homework. Key idea. Okay, so here let's look at A. A, we have an outside of the absolute value, -7. So that tells me we need to go up -7, which for normal people is down 7. So I'm gonna take my absolute value guy and I'm going to draw him right here. And what's great about absolute value is there's just like a 1-to-1. You go over 1, up 1, over 1, up 1, over 1, 1, 1, 1. You can do that same thing on both sides. So I start here at 0, 0, and I go to the point 10 or -10, 10, and I just connect them. And you'll see that it lines up super nice the whole way down. So that's our parent function. And now all you have to do is take that and shift him down 7 to make him stand out. I'm gonna make him a little fatter. I'm gonna say black, so that's the final answer. You put arrows on him because he goes out forever. Okay? So we've got down 7. Okay, for our next one, same thing. Take the parent function and just kind of put them on all your graphs. So start with the parent function, and then what change do we have? Here we've got a +3 change, so we're going to take our original guy. Oh, I didn't draw my path. We're going to go up 1, 2, 3 right there. So here we go. Just like that. And, you know, guys, if you want, You don't want your lines to go outside of the graph. You just want to hit to the limit. So I'm just going to kind of retrace this guy and call it good. Just like that. Hey, look at the beautiful graph we have. Amazing. Same thing down here. Ah, key idea. Come back to me. Weep. Put them down here just for funsies. Okay, so now we've got inside of our absolute value, we've got a -4. And remember, I should just copy this. Remember when we're inside of our absolute value, oh, come on, you can do it. I believe in you. That's left, but that's if positive. So left to -4 means to the right 4. So we take this guy, we move him. Pop. I'm going to trace him because he goes outside of my graph a little bit. Ta-da! But you should, I'm doing a bad example. These should be straight lines. So hold and let them snap. What a great graph we have. And then finally x plus 5, since we are inside of our absolute value signs, gives us a shift not up, but left 5. So careful, because when you see this +5, that doesn't mean go to 5, go to +5, it means go to the left. It means go to -5. So just a heads up with that. So we're going to start with our normal guy at our origin. We shift him to the left, over here. Ooh. But don't go down yet. That's a great question. What if we had both shifts? We could do both shifts. I'll show you right now. Let's pretend I said, hey, what if it's absolute value of x plus 5 minus 3? Then we would have a +5. But then we would take that, and since we have a -3 says, hey, your y needs to go down 3. So go 1, 2, 3, but why though? Because y, it's a shift in y. And then we bring this guy down all the way to 3, and he would go more like that. So that's what would happen if we changed the graph to go all the way up here. Ah, so you can have both. There, I just proved it to you. All right, now we're going to do the backwards thing. Let's say you need to take your absolute value and you need to make him go 11 units up. Well, you take your handy dandy shortcut. Love it, live it, memorize it, because it applies not to just absolute values. Okay, so we need to, you know what, I'm going to change this just a little bit. I'm going to say that plus k, that's your left. Okay, so our vertical changes are going to be blue. Our side-to-side changes, those are going to be yellow. Ready? Up, down, down, up, right, left, right, left. That's going to be super helpful. Okay, so up means y equals the absolute value of x, and then we need to add 11, plus 11. Then since we go right to left. Got y equals the absolute value of x, and then inside, we're going to the right, which is the opposite of left, so we need to have a -9. Got it? Okay, do the rest, and I will write answers for you. Ready, set, go. Yes, I know my pencil's loud. I don't know what to do about it. So if you have suggestions, that would be super great. Please let me know. Otherwise, here is everything you need to know. We're just checking that all of our side-to-sides are inside. Is that right? That's correct. All of our verticals are outside. That's also correct. Yay. Okay, your shortcut is right here. Know it, love it, memorize it, and have an absolutely fun time on your homework.